All right, today we're going to take a look at 2-7 dilations. So we can identify and create dilations in a coordinate plane. What I'd like for you to do is go ahead and do your warm-ups, follow the directions carefully, and hit pause and play when you're ready to check your work. All right, so it says multiply each of the coordinates by 3 and then draw the new triangle. So you can see the shapes are similar. One is just a lot larger than the other. So here's our first shape, and then notice this one actually went off the screen as well. All right, so what we actually did there, that's called a dilation. It is when we take a shape and shrink it or enlarge it. So a dilation is a transformation in which a figure is made larger or smaller with respect to a point called the center of dilation. So if I take a look, notice that each point is on those lines. So you can see how those corresponding points and these corresponding points line up. So how can we tell if it's a dilation? Well, what we're going to do is we're going to get out our ruler and we're going to see if we can find a center of dilation. So I'm going to connect each one of these points and see if they come together in the same spot. So if I look, yep, this right here, this is what I would call the center of the dilation. Now if I look here, of course I can connect my points here, but if I look, these are not coming together in a point. So this is a no, this one was a yes. This is actually a slide. I'm just moving it this way. You'll see how if I connect those corresponding points, I don't get a center of dilation. So what I'd like for you to do is take a look at 1 and 2 and let me know if these are a dilation. If I look here, believe it or not, this is actually a reflection, but I can take a look. I've got the same distance apart. Now here, when I go to check this, turns out my center of dilation is pretty far away, but you can see that those points are all coming together at a common spot. So this is actually what's called a scale factor. So the original figure and the images are similar, same shape. The ratio, so those side lengths that we're talking about, so the ratio of the side lengths of the image to the corresponding side lengths. So this side length and this side length, these ratios are all the same, and we call that a scale factor. Now that goes back to actually our warm-ups, when our scale factor for our warm-ups was actually 3 because we multiplied by 3. Now if you recall, when we multiply by a number greater than 1, our product is going to be larger than our factors. But if I multiply by a number smaller than 1, I actually get a lesser value of my product. So when our scale factor is greater than 1, we call it an enlargement. So it's getting bigger. If my scale factor is less than 1, we have what's called a reduction. So it is smaller. So what I'd like for you to do in example 3, draw a triangle ABC with a scale factor of 3 and identify the type of translation. So we're going to do just what we did in the warm-ups. So I've got A at 1, 3, B at 2, 3, and C at 2, 1. Now what I want to do is multiply both X and Y by 3 so that my new vertices of A prime, B prime, and C prime. So let's see, I've got A prime, B prime, and C prime. So 1 times 3 is 3, 3 times 3 is 9. 3 times 2 is 6, 3 times 3 is 9, 2 times 3 is 6, and 1 times 3 is 3. So now I'm going to go ahead and graph this. So I've got 3, 9, which is A prime. B prime is at 6, 9, and then C is at 6, 3. So when I draw this shape, you'll notice that I'll also have a center of dilation. So when I connect these, they all come together at one point. So if I'm multiplying by a number greater than 1, I have an enlargement. So the dilation is an enlargement. It's getting bigger. So now here, I have a scale factor of 1/2. So I want to multiply all of these vertices by 1/2. So I have W, X, Y, and Z, and W is at -4, -6. I have -4, 8, 4, 8, and 4, -6. So next, I'm going to multiply all of these by 1/2. I just like fractions better. So now I want to know my vertices of W prime, X prime, Y prime, and Z prime. So I'm taking half of all of those. So now I have -2, -3. I have -2, 4. Then I have 2, 4, and 2, -3. So I'm going to go ahead and plot these. So I have x1, or x prime, y prime, w prime, and z prime. Now, my shape got smaller, so this dilation is a reduction. Nice. All right, go ahead and try on your own 2 or 3 and 4 and come back and check your work when you're done. Go ahead and hit pause now. All right, go ahead and check your work. See how you did. So the first one multiplied by 2, so that is an enlargement. Here multiplied by 1/4, so that is a reduction. So let's take a look at example 4. The vertices of a trapezoid A, B, C, and D. Dilate the trapezoid with respect to the origin using a factor of 2. Then translate it 6 units up and, or I'm sorry, 6 units right and 2 units up. So the first thing we're going to do is draw our image. So I have -2, -1. That is A. B is at -1, 1. C is at 0, 1. And D is at 0, -1. So I've got my little shape here. Now I want to multiply that by 2. So I'm going to have A prime, B prime, C prime, and D prime. So I've got -4, -2, -2, 2. I've got 0, 2, and 0, -2. So I'm going to go ahead and switch colors here so we can see it a little bit better. So let's see, I've got A at -4, 1, 2, 3, 4, -2, 1, 2. So here's A prime, and then I've got B at -2, 2. So it's B prime. C is at 0, 2, and then I've got D prime. Now the directions say translate 6 units right and 2 units up. All right, so let's see, 6 units right, 1, 2, 3, 4, 5, 6, 2 up. So this is C prime, so 1, 2, 3, 4, 5, 6, 1, 2. Double prime, and let's see, 1, 2, 3, 4, 5, 6, 1, 2. A double prime, and then B double prime. So a lot going on there, so that my new points, A double prime is at 2, 0, B double prime is at 4, 4, C double prime is at 6, 4, and D double prime is at 6, 0. All right, so let's take a look. So this looks like this image has been flipped upside down. So I've got my new image right here. So let's see, we've got this to here. So it looks like we've got from here to here, that is a reflection in the x-axis, and then this one looks like it's twice the size. So if I look here, this is 2, -1, this is 4, -2. So that is a dilation of 2. Now again, are there other options there? Absolutely there are. It's not the only way to get to those 2 different shapes. All right, go ahead and try on your own number 5 and 6. Hit pause and play when you are ready. All right, let's take a look. So we've got our original figure, scale factor of 4, then a rotation around the vertex of C. So your new point 6, 9, 3, 3, 0, 3, and 0, 9. Now for 5, can you reflect the figure first, then perform the dilation? Absolutely. Lots of different options there. All right, everybody, have a great day. Talk to you soon.